Looking at this problem, in the arrangement of resistance shown below, the effective resistance between A and B is. For finding out the effective resistance, we know Westone's principle. If the resistors are in the ratio P by Q equal to R by S, then the current passing through the middle resistor or the galvanometer is 0. Therefore, we could look at this circuit as Westone's condition, or we could apply the Westone's condition over here. 5 by 10 is equal to 10 by 20. Since it is obeying Westone's principle, we can neglect this resistor. No current will pass through. Then look at the next condition. 10 by 15 will be equal to 20 by 30. Therefore, this is also obeying Westone's principle. Therefore, this resistor can also be taken out of the circuit since no current will pass through. Therefore, we could redraw the circuit diagram into a circuit diagram like this. 5, 15, 10 and 30. Then not 5, 15, there is a 10 over here, I forgot, and there is a 20 over here. Then the total resistance will become 5, 10 and 15 are in series, therefore it is 30. Then 10, 20 and 30, they are in series, therefore it is 60. Therefore, effective resistance Rp is equal to R1 R2 divided by R1 plus R2, that is 30 into 60 divided by 30 plus 60, and you will get an answer of 20 ohm. Therefore, option A is the correct answer. Let's look at the next question. In the following diagram, the charge and potential difference across 8 microfarad capacitor will be respectively. This is a problem connecting capacitor, and they are asking you the charge and potential difference across the 8 microfarad capacitor. What is the 8 microfarad capacitor? This is our 8 microfarad capacitor. Okay, then in order to solve this, we could find out the effective capacitance of the circuit. We could find out the effective capacitance of the circuit, for which we could apply our nodal analysis. That is, let's put this node as A. Therefore, this node is A, this node is A, this node is also A, since we didn't jump past any capacitor. Okay, then if I am taking this point as P, we cannot say this point is P. It's because we have jumped past a capacitor. Let's call this point as C. If this point is C, means we could clearly see this point, they all will be CC, and this point will be also C. Since we have marked all the nodes, we will say, let's write A, B and C. Then let's fill the capacitors. This capacitor is between A and C. Therefore, we are having a capacitor of 6 microfarad over here. This capacitor, it is between C and A. Therefore, I am having another capacitor of what? 4 microfarad over here. This 8 microfarad capacitor, it is between A and C. It is between A and C means it is connected like this, and it is 8 microfarad. Okay, this one. Then this 7 microfarad capacitor, it is between C and C. If it is between C and C, we have to mark a capacitor like this, but it won't be having any effect. And this 9 and 9 microfarad capacitor, it is also between C and C. Therefore, I will have to draw another capacitor like this. This is our 9, 9. Then this is our 7. And finally, the 36 microfarad capacitor, it is between C and B. Therefore, this is our next capacitor. It is between what? It is between C and B, therefore 36 microfarad. And you could clearly see if these capacitors are connected like this, there won't be any charge stored, therefore we could neglect it from the circuit and we could redraw the circuit diagram like this. For 6 and 8 microfarad capacitors, they are connected. This is for 6 and 8 microfarad capacitor, they are connected in series to a 36 microfarad capacitor. This is the equivalent diagram. Then what we can say from this is, we can say this combination, since it's parallel combination capacitor, we could directly add 4 plus 6, that is 10, 10 plus 18 plus 36 microfarad capacitor, which is connected to a 40 volt battery. Let me write it like this: 40 volt battery. Therefore we could say the voltage, the total, then we could solve it further. That is, if these two are in series, the effective capacitance will be Cs is equal to C1 C2, that is 18 into 36 divided by 18 plus 36, and if you are solving this, we will get 12 farad. Therefore, the capacitance is 12 farad. The equivalent capacitance is 12 farad. It is connected to a 40 volt battery. Then, since we know C and V, we could find out Q. Q is equal to CV, that is 12 into 40, and that you will get 480 coulomb. This is the charge accumulated over this capacitor. It is 480 coulomb, and you know in series combination the net effective charge will be equal to the charge across each capacitor. Therefore, this charge will be also 480 coulomb, and this charge will be also 480 coulomb. Since we require the charge and potential on 8, let's solve this. From this we know Q and C. Therefore, V is equal to Q by C, that is 480 by C, it is 18, and if you are getting 480 by C, that is the voltage across the 18, the potential across the 18 farad capacitor, it will be 480 by 18, that you will get 26.66 something. Okay, we are getting an answer of this. Then the potential of 18 farad capacitor will be equal to the potential on each. Since parallel combination, potential will be same. Therefore, the potential on 8 farad capacitor will be 26.66, and if the potential is 26.66, are we having an answer like this? Looking at this, this is the most nearby answers is 26.66 can be approximated to 27. Therefore, voltage is 27. This should be the answer. Then let's find out the charge also. In order to find out the charge on this capacitor, let's redraw that capacitor situation. We know the capacitance is 8. As we know, the potential is 26.66. Therefore, Q is equal to CV, that is C is 8 into V is 26.66. And if you are solving this, we will get 2112.8. Okay, we'll get 2112.8. Then this Q is near to this value. If you're taking V as 27, and if you're solving, you will, I think you will get approximately this value, therefore this is the answer.